to our channel. My name is Dmitry and I'm a part of the Exactpro research team. Exactpro is a company that builds software to test software. Check out our website if you want to learn more about us. And don't forget to subscribe to this channel and hit the bell button to see the upcoming videos. We are continuing our series of videos based on the ISTQB Foundation Level syllabus. Today we will review second part of Chapter 2, titled Testing Throughout the Software Development Lifecycle. If you missed the previous videos, you can find the links in the description below. Let's pick up where we left off. We ended the last video mentioning test levels. The ISTQB syllabus identifies 4 of them: component testing, integration testing, system testing, and acceptance testing. Let's look at what happens in each of them. Component testing or unit testing searches for defects in modules that are separately testable. It may be done in isolation from the rest of the system, but most often stubs and drivers are used to replace the missing software and simulate the interface between the software components. A stub is called from the software unit under test, a driver calls on the unit under test. Component testing is usually performed by the developers themselves. Sometimes writing automated test cases may precede writing the application code. For example, consider test-driven development. It is based on cycles of designing automated test cases, then building and integrating small pieces of code, then executing the component tests, and correcting any issues that arise. This process continues until all components are built and all the tests are passing. It is an example of a test-first approach. Integration testing focuses on interactions between components. For example, if we're integrating module A with module B, the tests should focus on interoperability between them, not the functionality of individual modules, since that should have been covered during component testing. The team that later became Exactpro Systems was initially hired to do integration testing, and before the project started, we were told that the scope is limited to integration only because every vendor is supposed to perform thorough functional and non-functional testing of their corresponding modules. Our ability to prove that the approach was lacking is one of the main factors that enabled us to achieve Exactpro's early success. Integration strategies may be based on the system's architecture, for example, top-down or bottom-up, or its functional tasks. In order to simplify defect isolation and bug detection early in the SDLC, integration should be incremental, adding a small number of components at a time, rather than a big bang, which is assembling all components at once. The greater the integration scope, the more difficult it becomes to isolate defects to a specific unit. Continuous integration should include automated integration testing, ideally at multiple test levels. System testing. This level of testing focuses on the behavior and capabilities of a whole system, its functional and non-functional requirements. System testing is typically carried out by independent QA teams based on specifications. Specification inconsistencies can lead to a lack of understanding of the expected system behavior. Such situations can cause false positives and false negatives, which waste time and reduce effectiveness. The early involvement of testers helps to mitigate such issues. Acceptance testing estimates systems readiness. Here we have to establish the confidence in our end product. It should work as expected, and all of the functional and non-functional characteristics should be specified. Defects may be found during the acceptance testing, but finding them is often not the objective. Unfortunately, discovering a significant number of bugs during the acceptance testing may in some cases be considered a major project risk. Alpha and beta testing are typically used by developers of commercial off-the-shelf software who want to get feedback from potential or existing customers before the software product is put on the market. Alpha testing is usually done on-site, and beta testing is often conducted at testers' locations. Project teams can employ various forms of acceptance testing during each iteration, focused on verifying a new feature against its acceptance criteria and on validating that a new feature satisfies the user's needs. To bring this closer to our work specifics, there are 2 types of users involved in acceptance testing: internal and external. In the world of exchanges and clearing, internal users are operations and market control. External users are traders, clearing members, and other market participants. Stock exchanges usually allocate dedicated test environments for market participants to perform their own testing. Test levels are quite straightforward. Test types, on the other hand, are a bit trickier. First of all, a test type is a group of test activities aimed at a specific characteristic of a system. They can check functional or non-functional attributes of a program, and that's one way of classifying them. Another way of categorizing them depends on your access to the internal code. Here we divide test types into white box, black box, and gray box testing. Functional testing. As the name suggests, it evaluates functions that a system should perform. This kind of testing considers the software's behavior, so black box techniques may be used to derive test conditions and test cases for the component functionality. Functional test design and execution may involve special skills or knowledge, such as understanding of the particular business problem the software solves. Testing functionality can be requirements-based. That's when we use a specification as the basis for designing tests. Business process-based. That's when we use the knowledge of field experts who can help us understand how the system should function if the specifications are missing. Or experience-based, when test cases are derived from our know-how, based on logical conclusions and past experiences. Here's a simple example of functional testing performed using our proprietary tool called Selfish. The workings of an exchange system come down to sending and receiving messages. When we send a valid order to the system, we'll receive an execution report message with corresponding fields. We compare its fields to the expected ones. If they match, we conclude that the system works correctly. The second step involves sending an invalid order. The execution report message in this case should reflect the fact that the order doesn't meet the requirements listed in the specification. The functional testing answers the question of what. What is the software doing? On the other hand, non-functional testing answers the question of how. How well is the software doing it? Like functional testing, non-functional testing should be performed at all test levels. For example, we perform a load test, where we load the system with the expected production-like rates and keep it that way for an extended period of time, checking how much resources it consumes. Or we can run a stress test by sending orders too fast and then analyzing how our actions affect other users. Another thing we can throw at the system is a performance test, where we check how well it copes with extreme amounts of data. For example, how many transactions per second a gateway can handle without queuing. The order of these tests depends on the set priorities, but all of them can be done without bespoke load injector tool, while supplementary data analysis can be executed with a tool called Shsha. As for the trading systems, high performance and resilience are the key quality characteristics and a must-have in our industry. Evaluating them is the reason why we conduct non-functional testing. The load level of trading systems usually varies from low values to microbursts totaling 50,000 to 300,000 messages per second. A human is unable to generate this number of requests manually, so Load Injector addresses this challenge. As mentioned earlier, you can also differentiate between the types of testing by how familiar you are with the code structure. So here are the three shades of the monochromatic approach: white box, black box, and gray box testing. White box testing. Testing the structure of the system is also extremely important. This kind of testing is often referred to as the white box or the glass box because we're interested in what's happening inside the box or with the source code. The best approach here is to measure the code coverage. In order to achieve that, the tools assess the percentage of executable elements that have been exercised by a test suite. Black box testing doesn't concern itself with the internal structure of the software or its code. The only purpose of such tests is to confirm that the software does what it's supposed to do. A number of test cases are built around the specifications and performance. Both valid and non-valid inputs are used to receive the expected outputs, which get analyzed. Gray box testing. This one is a combination of the previous two. Gray box testing is most frequently used when we have access to the internal structure of the system, logs or internal GUI, but not to the complete source code. Using that knowledge, you can trace some queries to get a better idea of what's going on. For example, we have access to the backend database structure and can check if a particular column is absent from a specific table. The last thing we're going to talk about in this segment is maintenance testing. These tests are executed on the software that's already deployed. It is necessary because software systems that have been released into live production typically remain in service for a long period of time. They still get updated and upgraded to keep up with the new requirements. Otherwise, the system will quickly become obsolete. Because of this, failure to do maintenance testing may result in accumulation of errors, which in turn will render the system unusable after a number of upgrades. These tests are triggered by modifications, migration, or retirement of the system. From the testing point of view, there are two types of changes. 1. Planned modifications. That's pretty much self-explanatory. They comprise over 90% of all maintenance work on systems. And 2. Ad hoc corrective modifications. which deal with defects requiring an immediate solution. For example, a production run which dumps late at night, or a network that goes down with a few hundred users online. During maintenance testing, it is also very important to carry out impact analysis. This is done with all stakeholders. All new changes get analyzed to see how they may affect the existing parts of the system, which is why regression testing and confirmation testing become an integral part of the whole maintenance process. This concludes our today's video. If you liked it, give us a thumbs up. In the next one, we'll continue talking about ISTQB Foundation Level syllabus, and we will focus on Chapter 3, titled Static Testing. Meanwhile, we do have a lot more interesting content on our channel, so feel free to subscribe and hit the bell button. Thank you for watching, and goodbye.